Welcome back to Bazai. Ever wondered what really happens when a Python script runs? In this quick breakdown, follow the journey from source code to a running program inside the CPython runtime, the reference implementation most projects use today. Source and compile. Start with a.py file written in a code editor, nothing special required. When execution begins, CPython doesn't jump straight into raw text. It first compiles the source into bytecode, an intermediate, platform-independent representation. This compilation happens automatically and in memory, no extra command needed. Think of bytecode as a compact instruction set that's simpler than Python syntax, but still high-level enough to be portable. Artifacts, the PYC cache. To speed up subsequent runs, CPython writes the compiled bytecode to .pyc files, usually inside the PyCache directory next to the module. On the next import, if the timestamps and flags match, Python skips recompiling and loads the cached bytecode directly. This is why a big project often feels faster after the first cold import. Bytecode cache turns recompilation into a quick file read. Module loading and imports. Next, the import system goes to work. It resolves module names, searches project folders, the standard library and site packages, and applies the finder/loader mechanism. For each module it loads, Python executes the module's top-level initialization code exactly once per process. If the cache is valid, it pulls bytecode from .pyc, otherwise it compiles the .py on the fly. Circular imports, sys.pathquirks, and namespace packages are all handled here. This is the machinery that makes Python's ecosystem plug and play. Execution on the PVM. Once modules are ready and the entry script is compiled, the Python virtual machine, the bytecode interpreter, steps through instructions one by one. This interpreter loop fetches an opcode, dispatches to a handler in C, manipulates the Python stack, and moves to the next opcode. Interpreting bytecode is incredibly flexible, great for introspection, dynamism, and rapid iteration, but it's also why pure Python is typically slower than compiled machine code. Performance notes. The interpreter's flexibility carries overhead. Dynamic typing, reference counting, and object boxing add costs per operation. The global interpreter lock GIL ensures memory safety for Python's C internals, which simplifies extensions but limits parallel execution of Python bytecode across threads. Developer tips. Warm imports. Run once to populate PyCache and improve startup for tools or CLIs. Profile before optimizing. Use cprofile, pyspy, or scaling to find hot code. Vectorize or offload. Replace Python loops with library calls that execute in C or on GPUs. Consider PyPy or specialized runtimes if the workload benefits from a JIT, and explore HTTP/3 or